we can do it that way as well. So there's a few options. Right now, I just want to make it more sensible. So we can make it 10. Oh, I'm sorry, hang on. Do. Oh, sorry about that. I had something else on another screen I'd forgotten about, and I want to take care of that. Bear with me. All right, back in the action. Okie dokie. So yes, so we're talking about this guy. There's actually more questions surrounding the display of this number than just the fixed. And actually, I look back at this and I kind of cringe a little bit because I just made all this up, like in the moment. It's not really based on anything. I just wanted to give an example of how algorithms become more complex. So 13.85 is a nonsense number, 10 is a nonsense number, 20 is nonsense. Um, all these calculations are nonsense. And the idea was, this is really where another part of the game where you really just want to go to a coffee shop with another kind of, D&D or role-playing person and say, hey, how are we, like, what's our canon, right? Like, how are we actually doing the math for these things? Is it consistent? Um, and that's going to make it easier later on when you say, well, how do we rebalance these things? Army vets are way out of balance in terms of how much they heal compared to carpenters. Let's look at the math. You're going to thank yourself if when you look at the math, it's not just a bunch of garbage in, garbage out numbers. So what I don't want to do right now necessarily is uh, add a lot of really nice formatting onto bad numbers. I'd rather have it remain a code smell. And a code smell is just something that you look at it and it just kind of makes you crinkle up your face a little bit because you're like, why is that way? And so every time we see that funky number, we're going to say, that's probably a place we need to look at. So it's a code smell. Candy Tree 95 says hello. Hello to you, Candy Tree 95. How was your morning? Okay, so one more time. Running through it. Yes. So continue. All right. So now we've got 133 as our hit points. That feels better. I say that because I really want to try out the dead thing. I didn't want to have to chip away at 133 hit points. All right. So, okay, so poor Gary again. Um, let's do this. So Gary heals Beth, and then Gary tries to um, hit Beth, but finds that he can't move. This this really aggravates Beth. She was a nice person. She trusted Gary. So while Gary got hit points are greater than 0, so while Gary has hit points greater than 0, we are going to hit him. There's no nice way to say this. There's no gentle way to say what we're doing now is beating Gary to death. So we're going to say that our response we're looking at is going to be hive mind. Dot execute. New game request. The game action we want is equal to game actions fight. The sender this time is going to be Beth, and the target is Gary. So hopefully you're trying to see how the API we're writing for these things really allows you to read out what you want to do, right? Like when we say, hey, we want to execute something, it flows very logically. We'll execute what? We want to execute a fight. Okay, well, who's doing it? Beth. Okay, who's she doing it to? Gary. That's all I need to know. Hive mind goes off, processes, and comes back. Candy Tree asks, what are we working on? So this is going to be a text-based multi-user dungeon, kind of an homage to the old school text and door games from the BBS days. The overarching idea here is that every week we go through a design pattern, and then we try to apply that design pattern to this concept of a game. So we're really here to learn and discover katas for keeping patterns fresh in our minds. But one of the issues you see online is you kind of get abandoned at the end of a very basic example. So we really want to try out the patterns and see if they're any good, or see if they make the application easier to use or easier to program. If they don't, we don't want to keep practicing them. If they're great, then we want to refine them. So that's kind of the idea. Oops. So back to the fun stuff, which is beating Gary to death. So let's just see what happens here. Let's get rid of this debug point. All right, so Beth attacks for 21. This looks good. Actually, a little better than I thought it would. That's nice. And you see, my hit points should be down. Let's see where we stopped. So we might have a bug here. Because Gary's hit points are 133. Gary's hit points are 112. Gary's hit points are 91. 70. 49. 28. Alright, so now that we're getting down to this last one, No. Now that'll play. So we've got a fight. And we're getting hit for 21 damage. And the target is. And the target has 7 hit points. So far, everything's all the plumbing's very nice. Everything's talking the way we want it to. The center checks state. The target checks the state. The hit points are -13. We set the game object to be out of play, and the actor state is dead. Okay, so we're gonna fix the display here in a second, but let's just look at what we've done so far. We've used the state pattern to add this ability in the game to beat someone to death. I know it's not the most, I guess, friendly example, but it's Gary we're talking about. So, we put that on the response stack, we return the response, and Gary's hit points are -13, and then we display the command. Let's also look at the hive mind for a second, and our response stack is 9. So we've kept track of everything we've done so far. And they're just all responses. And so if we really want to dig into one, we'll see the message, we'll see the amount, we'll see whether it's successful, we'll see the original request with the target and the sender. So we have this with the command pattern, we've got this built-in log. And so if we ever wanted to replay, which is a big part of one of the more advanced design patterns called event sourcing, if we ever wanted to replay these things and analyze what actually happened, we can do that. We can, in this almost kind of futuristic way, kind of investigate a scene based on what actually happened and in what order. So it's actually really cool. So we don't have a death response, right? And we do kind of want one of those. So let's go ahead and go in this display. So we're displaying the command. It was successful. And it was a fight. Here we go. So here's the bug. Let's just go and stop this. Inside of our program, we're only outputting the last command. We want to output every single one. Some of you who were watching were like, I saw that. I knew that. So that was a pretty easy one. So after every time we hit Gary, we want to output that Gary gets hit. What we also want to do is we want to have some sort of death message. So where do we put that? Let's go back to our hive mind for a second. So inside of our, inside of our hive mind execute, we're saying if the game state is out of play, we're doing that check. We have our check state. So we definitely want to have a way to piggyback on this. This one's going to be a little bit tougher. Because what we'd like to have happen is, if you die, we want to get back 2 messages. We want to get back the hit that killed you, and then also the fact that you died. Ashkatite says, considering all the attack damage are type int, do the hit points need to be float? So yeah, so float or double. And they might not, right? So that's actually a pretty good point to refactor. When we were first starting, and